Dear children, now let us solve the questions from the model question paper 1, 2, 3, 4 from the chapters Real Numbers. In each question paper, there are 5 marks question, 1 marks, 1 question, 1 question of 1 marks and 2 questions of 2 marks. Totally 5 marks questions are there in each question paper. Now let us take the model question paper 1. First question, the HCF of 3 and 5 is. Here you observe 3 and 5 are co-prime number. So as they are co-prime number, their HCF is 1. HCF of 3 and 5 is 1. 3 and 5 are co-prime number. They are not having any common factors other than 1. Then second question, prove that root 5 is an irrational number. Now let us prove that root 5 is an irrational number. Now let us assume to the contrary that root 5 is a rational number. Then you take, let us assume to the contrary that root 5 is a rational number. If you take root 5 is rational number, you can express this in the form a by b, where a and b are positive integers and they are co-primes. So you take, let root 5 equals a by b. A and b are positive integers and co-primes. Means their HCF is, that is, their HCF is 1. Now transfer this b to the LHS, that becomes b root 5 equals a. Now you take the square on both the side, taking square on both the side or squaring on both the side. By squaring on both the side, squaring on both the sides, right, b root 5 o square equals a square. It becomes 5b square. B root 5 whole square is 5b square. Root 5 whole square is 5 and b square. You got b root 5 whole square is 5b square equals a square. And you can verify here 5 divides a square. This implies 5 divides a square. Then 5 divides a also. A also. As 5 divides a square, 5 divides a also. So you take a equals 5c. As 5 divides a, you take, so you take, this is first one. Then you take, as 5 divides a, let us take a equals 5c. Again c is an integer. Then you take the square on both the side. That is taking square on both the side or squaring on both the side. that is a square equals 5c whole square. Then a square equals 5c whole square is 25c square. Then in the place of a square, you write 5b square. That is 5b square equals 25c square. That is from first. Then 5 ones are 5 5s are, you got b square is equals to 5c square. B square equals 5c square. Then this 5 divides b square. This implies 5 divides b square. Then 5 divides b also. As 5 divides b square, 5 divides b also. As 5 divides both a and b, 5 becomes the common factor of a and b. As 5 divides a and b, 5 is HCF of a and b. But here a and b are co-prime number, so you got an contradiction. But a and b are co-primes. But here what we got? 5 is the HCF of a and b. As a and b are co-primes, the HCF must be 1 only. But here we got 5. Therefore, we got a contradiction. It is a contradiction. This contradiction arises due to our wrong assumption root 5 is irrational. So our assumption is wrong. You can conclude that root 5 is irrational. Root 5 is an irrational. Question number 3. Third question. The product of HCF and LCM of two numbers is 2016. If one of the numbers is 42, then find the other number. Also find the HCF of those two numbers by prime factorization method. Here the product of HCF and LCM of two numbers is given. That is H into L equals H into L equals 2016. One of the number is 42. Let us consider A and B are the two numbers. The number A equals 42. What we have to find out? The other number b is to be find out. Write b equals question mark. Product of HCF and LCM is given and one of the number is given. We have to find the other number. If you take a and b are two numbers, then write given number is a, that is a equals 42. Then we have to find out b, the second number. To find this, we have to use the relation that product of two numbers is equals to product of their HCF and LCM. Here b is to be find out. Then you write a into b equals h into l. A and b are two numbers. H and l are their HCF and LCM. Then you write here second number b is to be find out. Then you write b equals h into l by a. B equals h into l is directly given, that is 2016 by a, one of the number, by 42. Then you divide 2016 by 42. You can divide here also 2 21s, then 2 1s, 2 0s, then 2 8s. 8 plus 1 equals 9 and 2 plus 1 equals 3. Both of them are in the table 3. 3 7s are 21. Then 3 3s are 9. 3 3s are 9. 1 8. 3 6s are 18. Now 7 1s are 7 4s are 28. And 5 is remaining. 5 6 7 8s are. So you got b equals 48. The other number is 48. Then we have to find out the HCF of these two numbers by prime factorization. Then you write the first number 42 and the second number 48. We have to find the HCF of 42 and 48. To find HCF of 42 and 48 by the prime factorization method. Find the prime factors of 42, means express 42 as a product of primes. Then 42 is having 2 in the unit place, then it is divisible by 2. 2 2s are 2 1s are. Then 21 is in the table 3. 3 7s are 7 1s are. You got that 42 is equals to 2 into 3 into 7. 2 into 3 into 7. Then you take 48. It is in the table 2. 2 2s are 2 4s are. Again it is divisible by 2. 2 1s are 2 2s are. Again it is divisible by 2. 2 6s are 2 3s are 3 1s are. You got that 48 is equals to 2 into 2 into 2 into 2, that is 2 power 4 into 3. Here HCF is equals to, for HCF we have to consider the common. What is common here? 2 is there, 2 power 4 is there. For HCF we have to consider the lowest power, then you write 2, and 3 is there, 3 is there, then you write 3. HCF is 2 into 3 equals 6. Model question paper 2. Again 5 marks questions are there. Totally 1 marks 1 question and 2 marks 2 questions are there. Now let us solve the question number 1, 2, 3 from the model question paper 2. First question, state the fundamental theorem of arithmetic. State the fundamental theorem of arithmetic. What is the statement of the fundamental theorem of arithmetic? The theorem says that every composite number can be expressed or factorized as a product of primes, and this factorization is unique apart from the order in which the prime factors occur. Let us write this fundamental theorem of arithmetic. fundamental theorem of arithmetic. Right? Every composite number can be expressed as a product of, you can write in the bracket factorize, or otherwise you write it as it is, as a product of primes. And this factorization is, and this expression is, or this factorization is, and this factorization is unique apart from the order in which the prime factors occur. Second question, prove that 2 plus root 5 is an irrational number. Let us prove this. What is the question? Prove that 2 plus root 5 is an irrational number. So let us assume to the contrary that 2 plus root 5 is rational. So right, let us assume to the contrary that that 2 plus root 5 is rational. If it is rational means you can express this in the form of P by Q or A by B. So right, let 2 plus root 5 equals A by B. What are A and B? A and B are co-primes, positive integers, and they are co-primes. A and B are positive integers and co-primes. Co-prime means their HCF is 1. Then here write root 5 in the LHS and transfer 2 to the RHS. That is root 5 equals a by b minus 2. A by b minus 2, that is root 5 equals, here you take the LCM. LCM is b and the numerator becomes a minus 2b. 2 into b, a minus 2b. Here a and b are the integers. So a minus 2b by b is rational. But as RHS is rational, LHS also becomes rational. But you know that root 5 is not rational, it is irrational. So here contradiction is arisen. This is the contradiction. This contradicts the fact that root 5 is irrational. So this contradiction has arisen because of our incorrect assumption or wrong assumption that 2 plus root 5 is rational. So you can conclude root 2 plus root 5 is irrational. So write, as RHS a minus 2b by b is rational, LHS root 5 also becomes rational. But we know that root 5 is irrational. It is a contradiction. This contradiction has arisen because of our wrong assumption. This contradiction has arisen because of our wrong assumption that, or incorrect assumption that, wrong assumption that 2 plus root 5 is rational. So we conclude that, that 2 plus root 5 is irrational. Question number 3, third question. The lengths of two rectangular tables are 84 cm and 126 cm respectively, and both have a width equal to 42 cm. Find the maximum length of a square glass sheet that can be exactly fit both the tables. Also calculate the total number of glass sheets required to fit each table. In this question, length of the rectangular table are given. They are 84 cm and 126 cm. Width of both the table are equal. They are equal to 42 cm. Here we have to find the maximum length of square glass sheet that can exactly fit both the tables. Means we have to find the HCF of this 84 and 126. So write, to find the maximum length of glass, square glass, you take glass. We have to find the we have to find HCF of 84 and 126. Use the prime factorization method and find the HCF. Then you take 84, 2 4s are 2 2s are 2 2s are 2 1s are 3 7s are 7 1s are. Then you write 84 equals 2 square into 3 into 7. 2 square into 3 into 7. Then you take 126 and factorize it. 126, it is divisible by 2 as the unit digit is 6. 2 6 are 2 3s are. Now it is not divisible by 3. Now you divide it by 3 because the sum of 6 and 3 is 9, which is in the table 3. 3 2s are 3 1s are. Again it is divisible by 3. 3 7s are 7 1s are. You got 126 equals 2 into 3 square into 3 square into 7. Now you take the HCF. For HCF we have to consider only the common. Here 2 square is there, 2 is there. We have to take the lowest power, that is 2. And 3 is there, 3 square is there. We have to take the lowest power, that is 3. Then 2 into 3. Again 7 is there, 7 is there. We have to take 7 into 7. 2 into 3 into 7. 2 3s are 6, 6 7s are 42. 42 centimeter. Here they are in centimeter. Then you write 42 centimeter. And the width is 42 centimeter. And the length of the square is 42 centimeter. Then you will get the square shaped means 42 width, 42 length. And how many glass sheets are required? Here if you consider these two tables, both of them are having same width, 42. And consider this is another one, this is also 42, and the lengths are here 42 and 42. Here 42 into 42 into 42. How will you get this? To find the number of sheets for each table, you divide 84 by 42 and 126 by 42. Then you write, to find the number of sheets required to fit first table 84 by 42, second table 126 by 42. Then you write number of square glass sheet first one 40, it is first one is 84 by 42. 84 by 42. 42 ones are 42 twos are, which is equals to 2, and the other one 126 by 42. 42 ones are 42 threes are. You can divide it. 126 by 42. 42 into 3 is 126. 42 into 3. 2 3s are 6. 4 3s are 12. 126. So 42 ones are 42 twos are 42 ones are 42 threes are. First table requires 2 sheets. Second table requires 3 sheets. Right? For first table, two sheets. For second table, 3 sheets. Now let us come to the model question paper 3. First question. Any composite number can be expressed as the product of. Any composite number can be expressed as a product of prime numbers, prime factors. So option C is the answer. Any composite number can be expressed as a product of primes. Second question. Prove that 2 plus root 3 is an irrational. The question is, prove that 2 plus root 3 is irrational. So let us prove this. Let us assume to the contrary that 2 plus root 3 is rational. Let us assume to the contrary that 2 plus root 3 is rational. As 2 plus root 3 is rational, you can express this in the form a by b, where a and b are positive integers and they are co-primes. So you write, let 2 plus root 3 equals a by b. What are a and b? A and b are positive integers and co-primes. A and b are positive integers and co-primes. Co-prime is their HCF is 1. Then you transfer this 2 to the RHS, keep root 3 in the LHS. That is root 3 equals a by b, this a by b, and transfer this 2 to the RHS. Then root 3 equals, in the RHS take the LCM. Only the LCM is b. In the numerator, write this a as it is, a minus 2 into b. As the LCM is b, we have to multiply 2 by b, that is 2b. Here you observe a minus 2b by b in the RHS and root 3 is in the LHS. As a and b are integers and co-primes, a minus 2b by b is rational. As a minus 2b by b, which is in the RHS, is rational, the LHS root 3 also becomes rational. But you know that root 3 is not rational, it is irrational. In the RHS rational, in the LHS irrational, it is a contradiction. This contradiction arises due to our wrong assumption 2 plus root 3 is rational. So you can conclude 2 plus root 3 is irrational. Then you write, as RHS a minus 2b by b is rational, LHS root 3 also becomes rational. But we know that root 3 is irrational. Root 3 is irrational. It is a contradiction. LHS irrational, RHS rational. It is a contradiction. This contradiction arises due to our wrong assumption or incorrect assumption, 2 plus root 3 is rational. 2 plus root 3 rational. So we conclude two plus root 3 is irrational. So we conclude 2 plus root 3 is irrational. Next question number 3, third question. Find the HCF of 135 and 75 by prime factorization method, and then find the LCM of 20 and HCF of 135, 75. In the first step, we have to find the HCF of 135 and 75 by prime factorization method, and we have to find the LCM of the 20 and the number which is the HCF of 135 and 75. Write 135, factorize it. This 135 is not divisible by 2 as the unit digit is 5. Now you try it 5. 3, 5 plus 3, 8, 8 plus 1, 9. 9 is in the table 3, therefore 135 is also in the table 3, means it is divisible by 3. Then you write 3, 13 we have to take, 3 4s are 12 and 1 is remaining 15, means 3 5s are 15. Again 5 plus 4, 9, this is in the table 3, 3 1s are 3, again 1 is remaining, 4 minus 3 is 1, 15, 3 5s are 15. Then 3 5s are 15, 5 ones are, you got that 135 is equals to 3 into 3 into 3 into 5, means 3 power 3 into 5. Next you take the next number 75, factorize it. This is not divisible by 2, now you try it by 3, 7 plus 5 is 12, it is in the table 3, so you divide it by 3, 3 2s are 6, 1 is remaining 15, 3 5s are 15, means 3 into 25 is 75. Now it is divisible by 5, 5 5s are 25, 5 1s are, then you write 75 equals 3 into 5 into 5, that is 3 into 5 square, 3 into 5 square. Then HCF equals, here 3 and 5 are common, then out of 3 cube and 3 we have to take 3 for the HCF, take 3, and 5 square is there, we have to take 5, 3 into 5 equals 15, 15 is the HCF, so you write HCF of 135 and 75 equals what? 15. Then we have to find the LCM of 20 and HCF of 135 and 75, which is 15. Means we have to find the LCM of 20 and 15. We have to find LCM of 20 and 15. Factorize 20 and 15. 20, 2 tens are, 2 5s are, 5 ones. You got 20 is equals to 2 square into 5. 2 square into 5. Then you take the HCF of 135 and 25, that is 15. 3 5s are, 5 ones are. You got 15 is equals to 3 into 5. Then LCM. LCM is equals to, here 2 power 2 is there and 5 is there. So 5 is common, write that 5. And here what is remaining? 2 power 2. 2 power 2. And here the extra is 3. Then you write 5 into 4 into 3. 5 4s are 20, 23s are 60. Then LCM of HCF 135, 75 and 20 is 60. Now let us take model question paper 4. Take the first question. If P and Q are co-primes, then the HCF of P square and Q square is. Take the factors of P square. P square equals P into P and Q square equals Q into Q. As P and Q are co-primes, they are not having. As P and Q are co-primes, their HCF is 1. Their common factor is only 1. So, here you can take the HCF is also equals to 1. HCF of P square and Q square is equals to 1 as P and Q are co-primes. So, what is the answer? The answer is option B, 1. Second question. Prove that 5 minus root 2 is an irrational. Let us prove that 5 minus root 2 is an irrational number. So let us assume to the contrary that 5 minus root 2 is a rational number. So we take, let us assume to the contrary that 5 minus root 2 is rational. If 5 minus root 2 is rational, you can express this in the form A by B, where A and B are positive integers and co-primes. So write, let 5 minus root 2, 5 minus root 2 equals A by B. A and B are positive integer and they are co-primes. Now you transfer this 5 to the RHS, that you will get minus root 2 equals A by B minus 5. Then minus root 2 equals, in the RHS take LCM P and the numerator becomes A minus 5 into B, 5B. 5B. Here you observe the RHS and LHS. As A and B are positive integers, A minus 5B by B is rational. As the RHS A minus 5B by B is rational, the LHS minus root 2 must become rational. As RHS is rational, the LHS must be rational. But you know that root 2 is irrational, minus root 2 also irrational. RHS rational, LHS irrational. It is a contradiction. This contradiction arises due to our wrong assumption 5 minus root 2 is rational. So we can conclude that 5 minus root 2 is rational. So let us write, as RHS A minus 5B by B is rational, minus root 2 LHS minus root 2 is also rational. But we know that minus root 2 is, it is a contradiction. This contradiction arises due to our wrong assumption 5 minus root 2 is rational. This contradiction arises due to our wrong assumption Phi minus root 2 is rational. So we conclude Phi minus root 2 is irrational. Next question, third question of the fourth model question paper. If the product of LCM and HCF of two numbers is 2366 and their HCF is 13, then find their LCM. If one of the number is 91, then find the other number. Here product of HCF and LCM is given, and here H into L is given. H into L equals how much? 2366, and H is given. L can be found out by dividing 2366 by H by HCF. And to get the other number, we have to use the relation H into L equals A into B. Given that H into L equals 2366 and H equals 13, L equals question mark, and A is given 91, B equals question mark. Now you write the relation H into L equals 2366. H is given. In the place of H you write 13 into L equals 2366. So L equals 2366 by 13. Then you divide 2366 by 13. 13 ones are 13. 3 minus 3 0. 2 minus 1 1. Take this 6 down, and 13 8s are 104. 6 minus 4 is 2. Take this 6 down. 2 6. 13 2s are 26. You got 13 1s are 13, 182s are. L equals how much? 182. Therefore you take LCM equals 182. Then to find the other number, one number is given. To find the other number, use the relation A into B equals H into L. A is given 91, B is to be find out. H into L is given, that is 2366. Then B is equals to 2366 by 91. Then you divide 2366 by 91. If it is possible, here try to divide. 91 is in the table, 13 sevens are. So if you divide 91 by 13, 13 sevens are 91, 13 ones are 13, 106, 13 8s are, and 13 2s are. Then 7 ones are 7,
2s are 14, 4 is remaining, 7 6. You got B is equals to 26. B is equals to 26. Otherwise, use the division method. 2366 by 91. 91 2s are 182. 6 minus 2 is 4. And 13 minus 8 is 5. 5 4 6 is there. 1 6 is 6. 9 6 is 54, you know. 1 6 is 6. 9 6 is 54. So 91 6 is 544, which is equals to 26. Again you got the other number 26 only.